Okay, this lesson is on our other derivative rules, so these are the last ones that we're going to learn, finishing up with our shortcut rules. And so the first one is the derivative of log base A, and that one happens, A can be any number other than E. If it's E, then it falls in the natural log category, and we've already went over that rule. Again, if they don't put an A there, you have to remember that that is an understood 10. And so you have to think of that as being there, because in the rule we have 1 over x, whatever x is, and again that could be something that's not plain, and then the natural log of that base. And those are under of 1. It's on a fraction there. For absolute value, the derivative of absolute value, you put the absolute value of whatever you have as x over x, but then again, if it's not plain, then you end up multiplying by whatever the derivative of the inside is, so you have a chain rule that comes off of it. This is just that first step that takes care of the absolute value part. The last 4 arc trig functions aren't as commonly used as the arc sine and arc tangent that we did in our previous lesson, so I'm just listing them here, and you'll notice if you go to memorize them, the arc cosine is the same thing as the arc sine, except it's a negative, and the arc cotangent is the same thing as the arc tangent, except it's negative. So really, if you know arc sine and arc tangent, you also know arc cosine and arc cotangent, because you just have to make those negative ones. And again, the last 2 aren't as common, but I want you to still be able to use them if they come up. And if you'll notice again, one of those is positive, one is negative, but it's the exact same thing. And with all of these, if you have a plain x, then you just have this, but if the x is something like x squared or 5x, you will put that, all the places you see the x, in the formula, and then you will multiply by the derivative of that using your chain rule. So here's our introduction for our last 6 trig and other derivative rules. Okay, now we'll move to some examples. Our first example, we have arc secant of x squared, and I can still see the arc secant rule here. So our derivative will be, first we'll use the arc secant rule, and wherever we see the x, we will put x squared. So 1 over absolute value of x squared, square root of x squared squared. Notice that one, you're plugging in an x squared for x, so you get a double square there, minus 1. If you wanted to, you could write x to the 4th, because that does mean the same thing. Once you've completed your arc secant rule, you move to the inside, and the inside is x squared. So we multiply by the derivative of that, which is just 2x. Okay, for number 2, we have arc cosine, and that's our outside thing. So the derivative of arc cosine is negative 1 over the square root of 1 minus x squared, but in this case, instead of x, we have tangent x. So tangent x squared, or you can put tangent squared x, the way we write it with trig. And that takes care of your arc cosine rule, but then you have to do a chain rule, so the derivative of tangent is secant squared. Okay, for example 3, on the outside we have overall an absolute value function, so we're going to use that absolute value first, and then we're going to work our way to the inside. So our derivative of absolute value says, put an absolute value around it on the top, and then not on the bottom, but you keep whatever's inside the exact same as the original problem to begin with. So it looks like this, and then I multiply by the derivative of the inside to take care of that. And since this has a minus, I'm going to put this in big parentheses over here. And this will be a power rule, so 6 times 5 is 30, x to the 5th. And then I'm going to bring down the minus, and then I have an exponential rule, so 2 to the x times the natural log of 2. So this was our absolute value rule, because that was the biggest thing on the outside, and then multiplied by the derivative of the inside. And I said 2, but I forgot to write it down, so I'm going to come back, put my 2 in there. Okay, for example 4, it looks really unique. I have an absolute value outside of an absolute value. So I wanted to show you how it would work if they showed you something weird like that. And so you just work from the outside in. So the first thing on the outside is absolute value. So I have absolute value of whatever's inside, which also happens to be an absolute value. And then whatever's inside goes on the bottom without that absolute value from the outside. So as weird as it looks, we are doing that rule where basically the top is exactly like the problem and then the bottom is whatever the inside of that problem was. Then our next step is to look at what's inside. Well, what's inside is also an absolute value, so I have to do that again, but this time I'm down to one set of absolute value bars, and then on the bottom is what's inside of it. And then finally, I work my way all the way to the inside, and the derivative of 3x is just 3. Okay, number 5 is our log rule, because our most outside thing is a log. So the derivative will be 1 over whatever your x is, and in this case that is 5x squared, times the natural log of the base. In this case our base is 7. Again, if they didn't have a number there, it would be base 10. And that takes care of the log part. Then the derivative that you're going to focus on next is what's inside the parentheses. So the derivative of 5x squared would be 10x. Okay, with example 6, before I start to take the derivative, I'm going to rewrite it. And because I'm rewriting it, I'm just going to put y equals, not y prime equals. And I'm going to turn that square root into a 1/2 power. So x squared plus 2x to the 1/2 power. Then I go to my derivative. And again, the outsidemost thing is the log. And then the next, you still have this chain rule because this is to a power. But the most outside thing is the log because it is a log of this whole thing coming after it. So I do 1 over whatever the x is, which in this case is this whole parentheses thing, which was the square root. So 1 over x thing times the natural log of the base, which in this case is 3. And then I do the derivative of that inside piece, which is going to be a chain rule again. So 1/2, keep the inside the same, to the negative 1/2, and then finally multiply by the derivative of the inside. So I just work my way from the outside in one step at a time. Okay, when we get to example 7, I have a log rule, but I also have an absolute value rule when I get to it. And again, I don't have a base here, and when there is no base, it's an understood 10. Don't forget that when you're doing your rule. So my derivative, working from the outside in, because it is the log of this whole thing, I'm using the log rule first. So 1 over whatever my x is, and in this case that's this absolute value of this fraction, times the natural log of the base, and in this case our base is an understood 10. That takes care of the log, and I work to the inside. And the inside has an absolute value that I need to do first. So I repeat exactly what I have inside the absolute value bars on top and outside of the absolute value bars, or without the absolute value bars, on the bottom. So I've taken care of the log, I've taken care of the absolute value, and then I finally get to the innermost part, and that's a quotient. So a quotient rule. So bottom times derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, we're to example 8. And example 8 is a nice chain rule example, and again we're going to have 3 layers here working from the outside in. In each layer you keep the inside of that the same. So the overall thing here, the most outside, is the natural log, and it's the natural log of everything that's in parentheses here. So our natural log rule is just 1 over whatever that is. So I'm just going to write that down. And that takes care of the natural log. Then I move to the log base 5. log base 5 rule is 1 over whatever its x is times the natural log of the base. In this case, our base is a 5. So that takes care of my log base 5. And then finally I move to the sine x, and the derivative of sine is cosine. And this x was plane, so I don't have to also chain rule it. Okay, our last example, we have a product rule. This part is our first, this part is our second. So our derivative would be first times the derivative of the second. In the second, we have a log rule, so 1 over whatever our x is times the natural log of the base. And then times the inside, which will be 5. So first derivative of the second plus the second times the derivative of the first. And the first has your arctan rule, which is 1 over 1 plus whatever your x is squared. And then times our derivative of the inside of that, which is a 3. So first derivative of the second plus second derivative of the first. And that concludes this lesson.